In this video, we want to take a look at finding the average rate of change. That's really just going to be the ratio of how one variable changes versus how the other variable changes. If we think about this as a function where the one set of data represents an x and one data represents the y, what we're finding is the change in the y versus the change in the x. In another context, we would call that slope. So if what we're doing in these examples kind of seems familiar, that's good. All we're really doing when we're calculating an average rate of change is calculating a slope on a graph. In this problem, we've got the population in 2000, the population in 2010, and we're asked to find the average rate of change. The rule of thumb is if you are given data that includes time as one of the things, you should make that the x coordinate. So in other words, I would say 2000, 348, 194, 2010, 319, 294. So if I think of average rate of change as calculating the slope, I would take the difference in the y values versus the difference in the x values. Remember that order is important when we're taking the slope. So if I start with the 348 number minus the 319, that means I have to start with the 2000 because that's the x that's associated with the 348 number. So 348 minus the 319 number, 2000 minus the 2010, don't fudge the signs. You are going to get a negative answer here, but that makes sense, right? The problem said the population was decreasing. So it makes sense that the average rate of change is negative. It's going down every year. Now this label shouldn't be a mystery. All you have to do is ask yourself, what does that top number represent? It represents population or people. What do the bottom numbers represent? The year. So it's population or people per year. This is telling me on average, we lost 2,890 people every year in the city of St. Louis. Let's take a look at a more physics type example. So we have Kiko launching a rocket and calculating its height at various times. So the time and the height. Usually, like I said, we're going to make time our x coordinate and the height then would be my y coordinate. If we want to find the average rate of change for the height from 0 to 4.6 seconds, well, here's the 0, here's the 4.6. Again, it's basically just calculate the slope and simplify. So this case, the top numbers are the height, which is in meters, so 30 meters, and the bottom numbers are the time, so 30 meters per second. It's positive, so it tells me in that time interval, this thing is increasing in height. But if I go to the next part of the problem, it says calculate the average rate of change from 9.2 to 11.5. So now I use these two data points. And again, I'm going to take the difference in the x's divided by the difference in the y's. But this time when I do it, I get a negative number, and it's still meters per second. The negative number tells me by this point on this interval, it's decreasing. The rocket's already coming back. We might be asked to find the average rate of change without being given a data table. We might just be given a function, the actual rule, and specified an interval. But we're going to do it the same basic way. We just need to calculate our ordered pairs. So if they're telling us to find the average rate of change for the function on this interval, I will plug in each of those endpoints into my function, so f of -2 and f of 3, work it out. Input, output gives me my ordered pair. So -2,7 is one ordered pair. Input, output gives me 317 for the other ordered pair. After that, it's just calculating the slope. Now, sometimes they're going to give us some weird ones where we're not actually plugging in a number, we have to plug in something else. But we still use the same process. So we have to find f of this first thing, f of x, that was given, so that should be easy. F of x plus h, okay, that means this x plus h replaces this x up here. So it's going to be 2 times the x plus h squared minus 1, which is what I have written here. Now you notice that I have this trinomial all of a sudden. I'm not just squaring both of those things, I'm actually getting a trinomial because down here I have my note. If I have x plus h quantity squared, that means I'm multiplying it times itself, which means I'm going to have to FOIL. Then I will distribute my 2 and I will simplify where I can. That's about as good as it's going to get. So those are my data, those are my outputs here. These were my inputs. So we're going to do the same thing, the f of x plus h minus the f of x over the difference in the x's. So that's where this came from over on this side. And then let me see if I can get this to go up a little bit higher so you can see it. There we go. The top, when you remove the brackets, is going to simplify down very nicely. Same thing on the bottom. It's going to simplify simply to h, and then we get a final answer. Let's take a look at one more. What if I'm given a graph and I'm told to calculate the average rate of change? Well, if it says from x equals 1 to x equals 4, I need to find where x equals 1 is and go up and figure out what the coordinates are of that point on the graph. In this case, it's 1, 5. And we're supposed to go to x equals 4. So once again, I go up. There are the coordinates. It's going to be 4, 4. So when x is 4, y is 4, that's my ordered pair. Calculate the average rate of change, i.e. slope, and we get a negative 1/3. Does that make sense for this picture? Well, slope is the vertical change over the horizontal change. So let's take a look at our picture. We're going from 1, 5 down to 4, 4. That change vertically is just 1 unit, but it's down, it's negative. The change horizontally is 3 units, and it's going forward, so it's negative 1/3. Makes perfect sense. Let me know if you have any questions.